Hello there and welcome to this video. In science, marketing or other areas, we often collect data in order to gain some kind of insight. We want to understand relationships, reveal patterns or test hypotheses. This is the area of statistical analysis. Statistical analysis can be subdivided into 3 steps: descriptive statistics, inferential statistics, and presentation of data. Descriptive statistics is the simple process of describing your data. For example, we usually want to know the mean value or maybe the spread of our data. If you collect data on the body weight of children, you may want to know the mean weight and possibly also the standard deviation, which describes the variability of your data. The description of data is always the first step in an analysis. But usually we want to know more. We want to explore our data. We want to know if there are trends or if there are differences between samples. This type of analysis is called inferential statistics. So in inferential statistics, we try to find out if there are relations, trends, or differences in our data. A key point of this part of statistical analysis is that we always have data from a limited sample, but we want to generalize our findings. For example, if data from a sample of 30 participants indicates that obesity is related to a health risk, then we want to know if we can generalize this conclusion to all humans. This is meant with the term inferential. We make a conclusion based on the sample and generalize this to the whole population. To do this, we use statistical methods or tests. Typical questions we answer using these tests are: is marketing strategy A resulting in more sales than marketing strategy B? Or is there an increasing trend in global temperature? Or is there a significant relationship between smoking and premature death? All these questions are addressed by inferential statistics. When using statistical tests, we often make assumptions about the data. A statistician might say we use a statistical model. Some of these tests are based on specific assumptions about data distribution. These are parametric tests. For these tests, it is critical that the assumptions we make about our data are actually true. Otherwise, the results of these tests are incorrect. Hence, before conducting parametric tests, we always have to check the assumptions first. Other tests are more flexible and do not require data to follow specific assumptions. These are non-parametric tests. To find out which test is the correct one, there are certain criteria you can follow. Have a look at this video to find out more. Or if you are using the software GSS, simply follow the flowchart for test selection. You will be guided to the correct analysis. In summary, the purpose of such tests is to detect differences between samples or to discover trends or relationships in your data. A final step of each statistical analysis is the presentation of your data. This step is crucial because even if we did the most sophisticated statistical analysis, it only has an impact if people understand it. So pay special attention on how you present your data. Data can be presented in graphs or tables. Often a simple graph may be more intuitive than a very complex one. Here is an example of a very intuitive graph. You can clearly see the differences. You get an idea of the variability of your data by looking at these error bars, and the asterisk shows that there was a significant difference between the groups. A note on statistical software. If you are an advanced user, you can probably use the more complex but powerful solutions, such as SPSS, MATLAB or SAS. Or if you're into programming, R is a good choice. For beginners, it's best to use software which is easier to handle and which offers lots of explanations and examples, such as GSS. The purpose of GSS is to gently guide you through your statistical analysis and to let you learn statistics on the way, while conducting all the analysis you need. So this was a brief introduction into statistical analysis. Thank you for watching, and if you liked the video, please like, share and subscribe.